Let's talk about translating the square root function. And a translation is what's called a rigid transformation. And that means the size of our graph is not going to change. We're not going to do any stretches or compresses with this graph. We're just going to take it and slide it around on the coordinate plane. So all we're going to do with a translation is shift the graph up, down, left, or right. And what we're going to do is compare this graph, which in this problem is g of x equals the square root of x plus 1, to our parent function, square root of x. I've already graphed f of x equals the square root of x here for us so that we can do a comparison and see what happens when we put a plus 1 on the end of that parent function. What's it going to do to that parent function, both visually, how will the graph change, and then also what will happen to the domain and the range. So we're going to start off by creating a table of values for our g of x function, and we'll start by plugging in our 0, g of 0. So we'll do g of 0 equals the square root of 0 plus 1. The square root of 0, of course, is 0, and 0 plus 1 is 1. So our first point will be 0, 1. Next on our list is a half, so we'll do g of 1 half. So that's the square root of 1 half plus 1. So over on our calculator, we'll do square root of a half, which we'll just do as 0.5, and then plus 1 on the end. That gives us 1.707, which we'll just round to 1.7. Next, we'll do g of 1. That's also one we don't really need the calculator for. Square root of 1 is 1, and 1 plus 1, as far as I remember, is 2. Next is 4, so we'll do g of 4, and that is the square root of 4 plus 1. Square root of 4 is 2. 2 plus 1 is 3, so our next point is going to be 4, 3. And then finally, the last point in our table is going to come from our x value of 9. So g of 9 equals square root 9 plus 1. The square root of 9 is 3, and 3 plus 1 is 4. So that's going to be our last point, 9, 4. So now that we have our table filled in, let's go ahead and graph our points and see what this function looks like. Our first point on our table was 0, 1. And then we have a half and 1.7. I'm going to skip over that one since graphing 1.7 can be a little tricky. Let's go straight to the 1, 2. And then we've got 4, 3. And then finally 9, 4. And then we'll go ahead and connect our points. And there's our g of x function. And so what appears to have happened is it looks like this g of x function has just taken our parent function and raised the entire thing up 1 unit. So it looks exactly the same, except, as we expected from a translation, the whole thing just slid up 1 unit. So I think it's fair to say that at least an educated guess would be adding the 1 onto the end raises the whole thing up 1 unit. Let's talk about what happens to the domain and the range. The domain doesn't seem to change. Seems like the domain is still any number 0 or higher because we're taking the square root of x, and we don't want to take the square root of any number less than 0. That would cause us to have a imaginary number. And then our range, normally the range is 0 and up, but because we are now adding 1 onto the end, we now cannot get a number as low as 0. The lowest number we can get now is 1, so our range now changes. Instead of 0 and higher, it is now 1 and higher. So our domain stays the same as it does in the parent function, but now our range becomes different.